What is it like to be in a world of no electricity? What is it like to have devices that are not electrical or electronic? They say the foundation of technology originates from the discovery of electrons. And just this discovery brought about smart devices that we use in our everyday lives. We could have just accepted our early days of living, without all this smart invention. But the curiosity of man didn't give a chance. Man decided to evolve in medical health, security, communication, and other sectors. What this means is that man found a way to use this discovery of electrons to build smart devices like the phones, generators, television, industrial machines, refrigerator, and so on. Most of the smart machines we have today are electrical or electronic. Why? Because they function with electrons flowing through them. That is why they are called electrical or electronic devices. These electrons are negatively charged particles that serve as energy to power up these devices in order to operate. Now, it sounds like the two fields, electrical and electronics, they are very much alike since they operate with electrons. But no, they have great difference. And so, to understand their difference and also their relationship, let us discuss their field respectively. Electrical and electronics field is all about using the electrons to build technologies in order to enhance the standard of living for everyone. Without the use of electrical grids, there will be no power distribution for houses. Without the smartphones, how do we communicate? Without the use of automated medical equipment, how will medical affairs be run? Without the use of our electrical cars, how do we move from one location to another? Without the use of biometrics recognition that are powered up electrically, how will security take place? This concludes that the use of electrical and electronic devices are very, very, very essential for the standard of living today. Now, we are still explaining these two fields. At one end of the scale, it covers the production and distribution of electricity to homes, business, and industry. But while at the other scale, it covers ever more complex and clever devices on chips. While both fields relate to electricity, which is the flow of electrons, however, these two fields are distinct in terms of their applications, components, and underlying principles. All these would be discussed as we proceed. But first, what is electrical field? The electrical field is a broader field of generating and distributing power, dealing with high voltage currents, and focusing on energy conversion. This energy results from the interaction of charged particles, while for the electronics field is a subfield of the electrical field that focuses on the design and control of low power circuits using components like transistors to manipulate information within an electrical signal, essentially allowing for complex processing and data manipulation with devices like the computers and smartphones. Essentially, electrical systems use electricity to power things, while electronic systems use electricity to process information. When I chatted up the preface of today's tutorial, I said something there that in the electronic system, Their flow of electrons carries information that are connoted in zeros and one. But unlike the electrical systems, they don't really operate in that manner. The flow of electricity is to power the device to function. The electrons just flow through a conductor to power up the devices. I want you to take proper note of some key features and differences of both fields from the explanation that is given. Now, for the electrical, note the word dealing with high voltage current. We are referring to the typical voltage and power levels involved, which is above 100 volts. That means it can be 120 volts, 240 volts, or 480 volts. Meaning for an electrical machine to function, it requires a higher amount of voltage. Such machines or systems are the power transmission and distribution, industrial power system, electrical grids, high voltage direct current, HVDC. But now, for the electronic systems, it doesn't require such amount of voltage, rather a low voltage that is below 100 volts. It can be 3.3 volts, 5 volts, or 12 volts. Systems like the smartphones, robotics, IoT devices, insulin pumps, and so on. All this requires low voltage. Just like our smartphone, the right amount of voltage to come in during charging is 5 volts. The second key feature to take note is that the electrical engineering of field deals with the generation, transmission, and distribution of electrical energy or electrons, while the electronic engineering of field studies the flow of electrons in various devices and systems. Both fields of engineering also differ in terms of components used. Electrical is based on electrical components such as the cables, the switches and transformers, while the electronic uses more advanced electronic components such as the transistors and integrated circuits. Now let's discuss the relationship between the electricals and the electronics. Electrical is the foundation of electronics. This means that all electrical principles such as the voltage, current, and resistance are essential for understanding electronic circuits and devices. The electrical is like a mother term that encompasses the electronic field. It also means that without the principles of the electrical, the electronic cannot function properly because the electronic system draw their operations from the electricals. Second relationship is that many electrical systems, such as the power generation and transmission, relies on electronic devices and systems for control and monitoring. These are the two main relationships between electrical field and the electronic field. Now, what we have discussed today is just the introduction to electrical field and electronic field. The fields are very broad. There is much more to talk about. In our next class, I would like to discuss components of both fields respectively. I will also talk about the alternating current and the direct current and other subfields, because this will channel us to what our practicals will be looking like. Thank you very much for your time, and I hope to see you in our next class.